I have 5 minutes less, so I'll introduce myself. I'm a engineer and a creator, basically. I work with Sapient. My primary experiences have been with the banking industry, mostly with consumer banking for last many years. And and I'm going to talk about a topic called service mesh. This is a very focused topic on microservices. We have beaten the topic of microservices to death today. We heard a great keynote from Mark. We had a great talk on serverless. So we saw a lot about microservices, right? So I'd like to talk a bit ahead of microservices. So our journey of we decided to go with microservices, started implementing, and the challenges and the design patterns, what we found was important, and what industry got into, and that's where service mesh comes into, and I'll introduce that as I progress. So we all heard about monolithic architecture and all of that, right? So when I started my journey with banking, our banks loved their monolithic architecture. They loved it. They don't want to move away from it, and believe me, even today, if given an opportunity, they wouldn't like to move away from it. That's my experience, right? Who's challenging them? The fintechs, the smaller groups, smaller companies who are pretty aggressive, and they are pretty much disrupting their big businesses today. The banks I have worked with, they had 2 releases a year, 2 windows of 2 weeks. If I miss the window, it's next 6 months. So everything has to be tied down, clockwork. If I don't do that, don't release. So, but monolithic's not bad. A lot of things are good. Simple communication, simple application, one exception handling framework handles the overall framework itself. Easily handle performance because you have minimal layers of hops. So you have web layer talking to your middleware layer, talking to your database layers. So minimal testing and debugging, simple because you are testing one simple piece, right? But why do the bank move ahead? Because now changing or releasing something which is big took a huge amount of time, and they wanted to be fast. And the technology shape is changing, and they don't want like 2 years of discovery and a landscape change before they can come up with a new technology. And that's the problem. Today, maybe 2 years back, Angular was great. Today, React's great. By the time our banks move to Angular, the CTO is saying, hey, we need to move reactive. We're like, oh, so another 2-year plan, right? So we need to get into an architecture which is fast. I can release. But do you know what's the problem? What's the key concern of a bank? What's the key concern? Security. They hold your money, for God's sake. So they want systems to protect your money. And there's a good, and believe me or not, it's a saying I've heard in multiple banks who don't talk to each other. Don't fix it if it ain't broken, basically. That's their funda. But now they need to because the market's changing. So what do? They break down their businesses, they change into microservices, right? And I won't go into details of what's microservices, blah, 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 but what we've seen is a great shift of how the whole infrastructure changes from physical machines to containers, data centers to orchestrated platforms, services. We've heard a lot about that. So I'm going to talk about my journey, right? So 3 years back, a client comes to us and says, hey, I want you to build a bank for us, and I want that to be set up from scratch in 9 months. Good, once in a lifetime opportunity. Like we grabbed onto that, yeah, building a bank from scratch. Great. You have the full freedom to use all the latest technologies, use microservices. We want microservices. We want to use the latest cloud architecture, etc. So we were all excited, went into it. So, like, does this resonate with banking? Some of these terms. So when we started thinking the bank, and imagine the platform we're building is something like a Paytm app today. right? Everybody's aware of Paytm. It can do payments, you can check your balances, you can make transactions, and a couple of other bells and whistles, right? So we said, hey, great, we designed microservices, follow DDD model, let's get our design place, let's have transaction, balance, statements, and many others. We figured there are 30 microservices which we'll need to build. First week, we realized that it's just not the microservices, but they start talking to each other. So when I do a transaction, I need to update my balance. I need to update my statements. When a statement gets updated, I need to send a notification. And when transaction happens, I need to send a notification. So it's not just a simple microservice we're building. We're now dealing with a mesh of microservices who are talking to each other. And as we progressed, more microservices, more chatter. So as we realized that there was a huge communication. And do you know why a communication between microservices? Anybody? Because while we structure our business in microservices, like, okay, payments is one service and transactions is one service, they don't, in real world, they don't exist in isolation. When you actually run a real world application, they are bound to talk. The businesses are bound to talk. And that's what, and banks want to build frictionless service. So you click on something, your payments happens, transaction happens, you send a notification, right? So they start talking. Now what happens? We build microservices, we had teams. Each microservices have teams. Now client said, hey, we want to participate, so we'll give you teams as well. So we had 2 more teams from the client side. Okay, great. Then we decided, hey, the architecture is changing. Now we have some microservices we need to build on Node, and there's some we'll build on Play, because that Play works well in some areas and Node works well on some areas. And it kept so the complexity kept on changing, right? So what do you think? We started great. We took the latest architecture. We had the great vision. In first week, where do you think we are heading? Anybody? Good question, but good topic for another another talk. Sorry, but I'd love to answer that, but and Play, both are event driven, both are non-blocking frameworks, but Play is more based on Java architecture. Node is more on the JavaScript architecture. It's just at a very 10,000 foot view level. Play Aka is a framework which we are talking about, right? So coming back, where were we heading? We're heading to a nightmare where these services talk. Now what happens if one service fails? Say I'm making a transaction and my balance service failed. What happens? We don't know, because our developer would have written the code of connecting to that service, making the call, written all our exception handlings. If that failed, somebody's got to go deep into the logs, figure out where it failed, and fix it, go into the database and fix it, right? So where were we going wrong? The coders originally would have coded the communication framework. They would have written like new HTTP, making the call, checking for exceptions, etc. Now you have polyglot language, right? You have Play and you have Node. So the way you implement it will be different. And the biggest nightmare, right? Dependency across teams now. So the payments guy running after the transactions guy saying, hey, help me understand this. This is not working. And they say, I don't have time. I have a release in 2 weeks, right? So we were heading for a big problem, right? And we said something needs to change. So we decided to tackle this problem. And this is a theme. And what I'm going to talk about is not something new or not something unique. This is a theme of our engineering, making things simpler, abstract, decouple, right? That's where we go on, right? So we thought, let's do that. So all of these network issues, like making a call to a service, making sure what is the security protocol between the service, making sure we build what is the error handling, circuit breaking, jitter, how do we manage that between service? Let's abstract that. Let's not give it to the coder, let's abstract that. So we said we build a framework which basically manages service-to-service communication. And we give them as a library to our customers, to our developers. They start using it, right? So what they would have done, they would have written the business logic, and they would have written the network communication. Now, what they're doing is they import certain libraries, and now our microservices developers are focused on the feature, what they need to do. They don't need to focus on circuit breaking. They don't need to focus on, which service to call, or where to go, how to load balance. So all of that headache went out from our microservices feature team and maybe to a specific engineering team who focuses on libraries, basically. Great. So what do you think? Were we successful? Anybody? Sorry. Yeah? Yeah, so, but that's the question. What do you think, based on what I'm saying? Were we successful? Yes, we were, right? And why? Why were we successful? Because we're not talking about a huge set of microservices. We're talking about 30 microservices for the first year of release. Manageable, controllable. We had tooling like Dynatrace, etc., to manage most of the things. So we could succeed. But now let's move ahead a little bit. Let's look at this. Anybody great fan of Star Wars? Yeah. So this is called the Death Star diagram, right? What you see is Netflix's microservices and the chatter between them. Or what you see is Twitter's microservice and the chatter between them. Do you think if we went ahead and implemented what we did here, would we be successful? No, it's going to be crazy, nightmare, because we're talking about at least 15 different programming languages there, 100 different teams, maybe 50 different architects, right? So it's going to be crazy. And I'll show you how crazy it is. I don't know if you can see, I zoomed the Twitter's Death Star diagram 10 times, and you won't still be able to see the microservices. So there are so many microservices. We're talking about more than 500 microservices. But do you think this is abnormal? No, this is not. This is the direction we are going in. Yes?
What tool is that?
Sorry?
What tool are you using? What tool did it generate?
I didn't generate. It's more, I took it from Twitter. Yeah, but there are visualization tools which can generate this. So, and look at this Netflix's data flow pattern. Look at this. So a single request and going to multiple places. Now one of these nodes fail, it's a nightmare for you. It's a big nightmare. So, and this is what happened with Twitter, right? So this guy, he was responsible for the digital transformation from Twitter, moving from Ruby on Rails to a more of an agile and a microservices architecture. Once he had built that, instead of engineering, he spent almost hours debugging issues if a microservices went down, basically. And how would he solve the problem, basically? And that's where he thought, let's fix this, right? So what they did, or let's recap, right? What we did is we solved this problem by building libraries, right? But our libraries were still part of our code. They were still attached to the code, and they still got deployed. But this guy was brilliant, right? He said, let's abstract it out. Let's move it out, right? Let's take it out as a separate component and make it as a proxy, right? And let the microservice talk to each other through the proxy, right? Does anybody know what pattern I'm talking about? This is a specific pattern here. Sorry? Close, but this is called the sidecar pattern. So have you watched the movie Sholay? Like Amitabh Bachchan used to drive, and there was a sidecar, right? So his sidekick would sit inside it. The sidecar pattern comes from the sidecar on your bike, right? So your sidekick sits on it. He'll help you like with everything. Like you are the main crime fighter, but the sidekick helps you. So that's your sidecar pattern. But then this is not enough, because just proxy is just abstracting. How do we manage? So now they build a service control plane. Now each of these proxies deployed across it now connect to a service control plane. So all your logic of circuit breaking, load balancing, everything lies in the service control plane. Your proxy is just focusing on the communication between service to service, right? So how this helped? Like he built a product called Finagle within Twitter, became successful, moved out of Twitter, established Linkerd and Buoyant as one of the products, right? And this is one of even though this doesn't seem like a new technology by itself, but this is still kind of new in terms of adoption and understanding of how microservices talk to each other, right? And this is the definition. I don't want to repeat. So this is how your microservices would look like. Now, if you look at your Dockers, you have your individual microservices in your individual Dockers, you have your sidecar or your proxies in a separate Docker, and you have your service plane basically talking to each of your sidecar, making sure that the configuration is well managed, the governance is well managed, basically. So that's the whole idea. That's how it's structured. So how does it help? Now you move up to 500 services and above, you can still manage it, because now you don't have to worry about services failing. You can manage that, trap that, and you can get your services up pretty quickly, right? So that's basically the idea. We talked about it. It's not a new idea. It's basically abstracting it, modularizing it, moving it into a new structure, I'd say. Sorry. Sorry? I'll come to that, right? That's a very good point. So what impact does the sidecar has? So let's come back to the slide, right? What it does, it increases a hop for each service, right? So earlier, the communication would have been between service to service. Now it's service to proxy to service, right? So there is an increase of a hop, right? And that's one of the biggest challenges of adoption of this pattern, because not everybody is 500 microservices large. There are people who are 30 microservices like our firm. Why would they invest into transformation into something this if they don't foresee their infrastructure growing into that scale, right? And what happens with the performance, right? Primarily because this technology has not been adopted greatly into production. So nobody has seen the impact, basically. So fairly new from an adoption perspective. And that's what's the biggest challenge for this particular technology, the maturity and the adoption, basically. And that's what's going on right now. The other challenge is, we talked about serverless, right? And this is very specific to a container-driven approach. So what happens is, what happens when we go into cloud and we go into a serverless architecture, right? You can't do this. Your cloud provider needs to provide your your sidecar or your proxy. So how does that happen? That doesn't exist today, right? So from a serverless perspective, as the world is moving towards serverless, the adoption of service mesh may be a challenge there, right? So these are the two key challenges, right? And sorry. Yes. So one of the things we understand is, do you understand the circuit breaker pattern, right? So there were two, like, we manage it in a couple of ways, right? Let's use it in our parlance of the banking parlance, right? We cannot go with the approach of giving the latest data if your service is down to make it up, because each cent counts. If I'm looking at it, my service is down and I'm giving a report which is a cent down, then it's not right? So depends on how you've defined a circuit breaker pattern. You could go to a latest what do you say, the latest data, or you could give an error which your circuit breaker, your application can handle, basically. Did I answer your question? Like it's not a one like a single. There's no silver bullet of handling it, but at least you have a control plane across each service-to-service communication. Yeah, so that's another different topic for different day. It's AMQ, what do you say, CQRS and event-driven approach. So it's more of how do you handle distributed transactions using microservices, right? Because normal monolithic applications have your start transaction, end transaction, and do your stuff, right? But an event-driven approach and a CQRS-based approach would help you to manage transactions, rollback transactions within that framework, basically.
But in this web, like microservices, they does not provide a distributed transactions.
No, this is a very specific framework to just manage service-to-service communication. Its focus is to do nothing else. It's a translator. It takes away the headache. Yeah.
How can we handle the distributed transactions?
Correct.
Like if you type that CQRT and other framework, they do not handle clearly distributed transactions.
No, they do. Sorry, but we can talk about that, but they do. That's the purpose of those frameworks, is to make sure that you have distributed transactions. How much time do we have? Sorry. Okay. I could give you your 5 minutes of this. So I'd like to show you something. Can't show you a big demo or so, but what we did is we took Buoyant's service mesh. I set up Kubernetes and Docker on my system yesterday, and I wanted to see if we could show something to you while it's working, right? I wanted to show you the management piece and the ease of code piece, basically, right? So, sorry, before we go there. So the example, what we're using here, we've got like 4 applications or 4 services. We have a web application where you can actually send your votes as an emoji. So you can send random emojis to it. And the emoji service will actually identify what emoji you have actually sent. And based on that, it will just create a statistics of how many emojis were received, basically. It's kind of. So what's happening is there are 4 applications talking to each other, right? Normally we would have deployed them, have them speak to each other, right? What we did is we deployed them on the service mesh, right? So what happens? So this is a service mesh. Oh, sorry. My bad. Yeah. Sorry. My bad. 1 second. Yeah. So this is our conduit service mesh, and we have deployed our 4 applications here, right? And say, for example, I want to look at the voting bot. What it does, so the voting bot is generating traffic. There's no incoming traffic. So now for each service, I can now see my outbound traffic. And there are other things like you can create alerts, you can manage health, etc., right? And if I want to go to say my web app. Now the web app is receiving traffic from the voting app because it's like a batch job, and it's sending out requests to 2 different microservices. So if I look at my web app, these are my traffic to incoming traffic, a single traffic, and these are my 2 outgoing traffic to 2 different services. And this is where you can manage and control individual services and handle individual services, basically, right? What happens? How does the code look like? Okay. So I can't show you my previous code. It was at least 100 lines of code where we make one service call, or not 100, I would say, it's exaggerating, maybe 30 lines of code where we're making the call, making exceptions, making sure we are making a couple of other calls for error handling. This is the code for making the call now. So you have a conduit library, import it, and make the call to the proxy. Conduit proxy handles circuit breaking, conduit proxy handles load balancing, conduit proxy even handles service to service security, basically. So that's, so your code, and this is JavaScript, and this supports all the other frameworks, both Python and Java and Play. So this is how simple now for a feature developer to make a service call. Yes. Sorry. Good question. We do canary releases. Our microservices are more Docker, they're not serverless. And we've got like at least 20 to 30 instances of each service running. So we make small releases. And one of the things which circuit breaker helps is routing. So header based routing. So if our new requests come in from a new application, they route to a smaller application, test out, and we slowly upgrade our microservices. So it's like a, I'm trying to explain canary release in a 2-minute thing, but yeah. Yes. Okay, let's break it down, right? What is a circuit breaker in English language?
One is not running, you.
Okay, circuit breaker is coming from electronics or electricity. Okay, so what does circuit breaker do? Why would I need a circuit breaker at my home? It will switch off. Why? Correct, right? So that's circuit breaker. So it prevents a cascading failure, right? So it says, hey, I've got an error. Either let me give a graceful output saying, hey, I'm down, or find a scheme like some of my friends talked about, give the latest cache data for the time being, right? So that the system doesn't fail in a cascading fashion, basically. While this particular service, like you call a repairman, like what's the circuit breaker at home? It's a generator, inverters, and our circuit, right? Moment there is a load of electricity, our circuits goes down, our fallback is our inverters, goes up, you're watching some TV and fan, something's working, you call the repairman while you're continuing your basic function, your circuit's up, and you can switch on your circuit breaker, your basic business happens. So I'm just trying to use an analogy to. Hystrix or normally our service meshes have circuit breaker components inbuilt. API gateways, Hystrix have circuit breaker as a component inbuilt, basically. So that's all I had. Any more questions, or I'll give you back some of your time. All right, thank you so much.